Hey, so here we have a complex looking identity, and the question is asking us to show that sine cubed x plus cosine cubed x times tangent x is equivalent to sine x. So an important thing to remember is that when the IB asks you to show or prove, what they mean is that you only work on one side until you reach the desired result. So I'm going to draw a line right here. I'm going to draw a line right here to indicate that we only should be working on the more complex side. Usually, you want to be working on the more complex side and simplify it down, because trying to go from something like sine x into a much more expanded form like this could take a lot of mental gymnastics. So first, I want you guys to notice that there are a few ways you could write out this equation. So immediately, you should notice that tan x has no direct relation with the rest of the function, as you can't factor anything out just from the way it is written right now. So I'd like to write tangent x as sine x over cosine x instead. So here we'll have times sine x over cosine x. And immediately it's a bit nicer to look at because everything is in terms of sine and cosine. So what'll happen here is sine cubed x plus sine x times cosine cubed x, since it'll multiply into the denominator, all divided by cosine x. So here we have a common term in the top and bottom. There are 3 multiplications of cosine x here. So this cosine x and this cubed will cancel, and it'll give us a squared instead. So next what will we do? Since we don't have a denominator anymore, let's write it out. Sine cubed x plus sine x times cosine squared x. Now, what can we do? We can factor out sine x from both terms. You'll notice that there's the common term sine x and sine x here. Obviously, you can only do this when you have two things adding or subtracting. You cannot factor out sine x from two multiplying terms like this. That makes no sense, right? So let's factor out sine x from both. So we'll divide this term by sine x and this term by sine x. So you'll get sine x brackets. Inside you'll have this term divided by sine x. So you'll get sine squared x plus this entire term divided by sine x, which will be cosine squared x. And if you remember your identities, which you will have access to in your formula booklet, this will become sine x times 1, since sine squared anything plus cosine squared anything must equal 1, according to the Pythagorean identity. And now, this is equal to sine x, since sine x times 1 is obviously sine x.